All right, lesson 2.5. So this is where the factoring comes into play in this third section. We're going to find the zeros of the polynomial, but it's currently in standard form, and so we're going to have to factor each one before we can use the zero product property to solve. So remember that with all factoring, you always want to check, does it have a GCF first? And so when we look here, we realize it does. So I'm going to pull out the GCF of x, and I'm just going to write down that this is a GCF problem, and then it will actually also be a dots problem as well. It'll turn into a dots problem. So we factor out the GCF. We have y equals x, which basically means divide each one of these by x, the GCF, and you would get x squared minus 36. Now when you look back inside the parentheses here, you ask yourself, can I factor this further? What type of factoring am I going to use? It's two terms, and it is dots, and so we're going to go ahead and continue with that, square rooting the x squared and square rooting the 36. Remember to use your plus minus, and you would get, don't forget your GCF out front, x plus or minus 6, which if you break that up into the two expressions, one of them gets a plus and one of them gets a minus. Now we have our three expressions, and we can set each one of them equal to 0 and solve. So the first one, x equals 0. Nothing to solve there. It's already done. The next one, x plus 6 equals 0. And the last one, x minus 6 equals 0. Again, first one's already solved. The next one, we would want to subtract 6 to the other side, and we would get x equals -6. And the last one, you'd want to add 6 to the other side, and you would get x equals +6. And there you have your three zeros. X equals 0, -6, and +6. Take a minute, pause the video, and try the next two on your own. All right, so here we go. Checking for a GCF. I do have one. This one's actually going to be a GCF and an AC factoring problem. So the GCF, we pull it out. It's an x. That leaves us with x squared minus 7x minus 18. There's three terms in there. Do an AC factoring. A times c, that's going to give us -18, and our b value is -7. So the factors that end up working out there are -9 and 2. And so we always divide by a. -9 divided by a, which is 1. Doesn't simplify, so we can apply the x. +2 divided by a, which does not simplify, so we can apply the x and slide them both. And we would get y equals, don't forget your GCF of x minus 9, and x plus 2. And now I can set all three expressions equal to 0. And solve each one of them. First one doesn't need to be solved, it already is. The next one, add 9 to both sides, you get x equals 9. And the last one, subtract 2 to both sides, and you get x equals -2. Therefore, your zeros are x equals 0, 9, and -2. And the last one does have a GCF. It is a GCF of 2. So we pull that out. Y equals 2, parentheses, x squared plus 14, x squared plus 7x, and then plus 10. I forgot to divide, 14 divided by 2. And so we go ahead and look inside, and we're like, all right, yeah, I got three terms. Go ahead and, oops, lost my lights. AC factor. All right. AC is 10. The B value is 7. The factors that work out are 2 and 5. So take each one, divide by the A, the new A, not the original A. All right. 1x, and the other one is 5 divided by A, which is 1. Ready for sliding. Don't forget about that GCF out front. y equals 2, parentheses, x plus 2, parentheses, x plus 5. Set each expression equal to 0, including the GCF. And then remember back from example 2 in the first section, this doesn't have anything to solve for. There's no variable. And it's also not a true statement. So we say 2 is not equal to 0, and that's not a solution. Here, subtract 2 to both sides, x equals -2. Here, subtract 5 to both sides, x equals -5. And so therefore your zeros are -2 and -5.